This bird flock simulation is the implementation of the Boids algorithm from Craig Reynolds, with some modification. Boid is the contraction of bird and oid. Like in the Reynolds algorithm, only 3 rules are used by all the Boids to maintain cohesion, separation, and alignment. When these rules are given to a huge number of Boids, here 3000, an unpredictable behavior emerges with surprising results. For the cohesion, every Boid has a shortened sight, limited in distance and angle. Here, the angle of view is 10 degrees. When a Boid sees another one, he immediately tries to rejoin it. For the separation, every Boid tries to maintain a separation with the surrounding Boids. Each one can sense at 100 degrees around it and adjust its speed and heading to reduce the risk of collision. For the alignment, to stay together, each Boid tries to follow the same mean direction of the Boids it sees. As there is no leader, the flock can scatter and reform without any predictability. Here we can see the behavior of the flock around an obstacle. If you stay until the end of this short video, you'll see 4000 Boids flying around 4 moving obstacles. The simulation is single-threaded and it runs on the i7 CPU. The engine runs at 30 Hz and the video has been here accelerated 3 times to shorten its length. It is interesting to notice here how the Boids can move from a chaotic swarm to a coherent veil without any specific event or particular initial configuration. A 4th rule has been introduced to break a swarming. Whenever a body senses too many neighbors, it will try to escape by flying away, breaking the rule 1 and the rule 3. Now let's see how this simulation has been realized on vsTasker. This time we are going to learn how to define a component instead of using a solid logic. To avoid a combinatorial explosion when computing distances between thousands of Boids, we are using a special mechanism of vsTasker called proximity mesh. Each cell lists all Boids inside it. Any Boid can obtain the list of all the surrounding Boids at a certain distance and within a given viewing angle, with a light fast call, even with thousands of entities. Here we can see how the mesh's cells light up when at least one Boid is inside. In vsTasker, a proximity mesh is defined manually over the terrain and dimensioned accordingly to the expected population. Several meshes can be used at the same time. For defining obstacles, we are using the feature capability, which allows dropping any shape on the terrain. Now we select the Boid. We see it holds a specific group follow component with user parameters. This component contains the Reynolds algorithm. You can notice that it inherits from the proximity component as it uses the proximity mesh mechanism to work with surrounding Boids. A component is like a C++ class. It contains user parameters, methods, initialization section, and a runtime part with a heartbeat. Declaration. We define all the methods and variables needed for the algorithm to run. Above are listed all the variable data needed for the component. Note that the variable suffixed with a special mark will automatically produce a user interface. The initialization section will be called for all instances of the component. In this simulation, every Boid will carry their own component instance. The runtime part is the heart of the component. It runs at a given frequency, 2 Hz in this example, and verifies all the rules and a specific obstacle avoidance maneuver. Finally, the methods part, where all component functions are defined to simplify the runtime part. Components are the second most powerful feature of vsTasker after the logic. They are the devices which power the simulation and provide core functionalities. Now it is time to populate our scenario with 1000 boids made of a mix of different colors. In this simulation, we have 4000 entities and 4 moving obstacles. The video has been accelerated here again to make it more interesting. With 4000 entities running at 30 Hz, vsTasker outperforms other tools that are on their knees with only a few hundreds. If you need the tool for your AI algorithm, test benches, studies, you have here a robust, engineer-oriented, acclaimed framework for all your real-time simulation. You can download this example on the tutorial page of the product website. I hope that you have enjoyed this artificial life simulation and that you will start building your own soon using the free version that you can download on the website. Thank you very much.